The topic is circles. Circles. Now, if suppose there is a fixed point, consider C be a fixed point. P is a variable point. But always the distance between fixed point and variable point is constant. Then the locus of the point P is called a circle. The locus of the point P is called a circle. Now the fixed point is center and the constant distance is radius of the circle. The fixed point is center and constant distance is radius. Now if suppose center of the circle some h comma k, radius of the circle are units. Now equation of the circle is x minus h whole square plus 5 minus k whole square equals to r square. Equation of the circle with the center h comma k and radius r is x minus h whole square plus 5 minus k whole square equals to r square. If suppose the second degree general equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. It represents a circle. Always the coefficient of x square and coefficient of y square must be equal. Now a equals to b. Coefficient of x square equals to coefficient of y square. And coefficient of xy must be 0. Means h equals to 0. Now the second degree general equation in terms of x and y represents a circle. Then coefficient of x square equals to coefficient of y square and coefficient of xy is 0. Coefficient of xy 0. Coefficient of x square and y square both must be equal. The standard equation of the circle or general equation of the circle is x square plus y square plus 2gx plus 2fy plus c equals to 0. The standard equation or general equation of the circle is x square plus y square plus 2gx plus 2fy plus c equals to 0. Now its center equals to minus g comma minus f and radius equals to square root of g square plus f square minus c. Radius equals to square root of g square plus f square minus c. If suppose g square plus f square minus c greater than 0, then the equation represents the equation x square plus y square plus 2gx plus 2fy plus c equals to 0 represents a real circle because we get a real radius and center also real. If suppose e equals to 0, if g square plus f square minus c equals to 0, then in that case the circle represents a point circle. Point circle means it having only center but radius equals to 0. If g square plus f square minus c less than 0, the equation x square plus y square plus 2gx plus 2fy plus c equals to 0 represents an imaginary circle. Imaginary circle. Now we can do some problems. Now first problem, the centroid of an equilateral triangle is 0, 0. The centroid of an equilateral triangle is 0, 0 and the length of the altitude is 6 units. Length of the altitude 6 units. The equation of circumcircle of the triangle. The equation of circumcircle of the triangle. The given triangle is an equilateral triangle. All sides are equal. The sides of the triangle are equal. Now centroid of the triangle 0, 0. Centroid origin and length of the altitude or a perpendicular is drawn from vertex to base. It is called altitude. Length of the altitude equals to 6 units. Required equation of circumcircle of the triangle means a circle passes through 3 vertices of a triangle, then that circle is called circumcircle. Circumcircle of the triangle. Now, but given triangle is an equilateral triangle. For equilateral triangle, orthocenter, centroid, circumcenter, incenter all are same. Now, the center of the circumcircle, the center of the circumcircle of center of the circumcircle of the triangle is 0, 0 given origin and length of the altitude equals to 6, but centroid divides median in the ratio 2:1. Then radius of the circle or distance between centroid to one of the vertex equals to 4 units, remaining distance 2 units. Now radius of the circle 4 units and center 0, 0, then equation of the circle is x square plus y square equals to r square, but r equals to radius of the circle r equals to 4, r square equals to 16. Now answer is x square plus y square equals to 16, second option. Origin is center of the circle passing through vertices of an equilateral triangle whose median of length 3a. Whose median of length 3a, center origin. Then the equation of the circle, similar problem. The triangle is an equilateral triangle. Center origin and length of the median. For equilateral triangle, median, altitude, angular bisectors all are same. Now length of the median equals to given 3a, total length equals to 3a, then the distance between one vertex and centroid equals to 2a, remaining distance a. Now here center of the circle is origin and radius equals to 2a, radius equals to 2a, then equation of the circle with the center 0, 0 and radius 2a is x square plus y square equals to 4a square. X square plus y square equals to 4a square. Now third option is correct. Third option. For the circle x square plus y square minus 8x minus 10y plus 16 equals to 0, plus 16 equals to 0, then the point minus 3, 4, minus 3, 4. Given options lies inside of the circle, lies outside of the circle, lies on the circle, is center of the circle. Now if suppose the given circle consider S equals to 0, point x1 by 1. Now S11 nothing but the given point substituting in the equation of the circle, given point substituting in the equation. Otherwise the circle equation x square plus y square plus 2gx plus 2fy plus c equals to 0. It is considered S equals to 0 or standard equation of the circle. Point any point x1 by 1, any point x1 by 1. Now S11 nothing but x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. If suppose S11 greater than 0, S11 greater than 0, in that case the point lies outside of the circle. If S11 equals to 0, then the point lies on the circle. Less than 0, the point lies inside of the circle. The point lies inside of the circle. Now the given point minus 3, 4, given circle equation x square plus y square minus 8x minus 10y plus 16 equals to 0. Now S11 equals to, by substituting the point minus 3, 4 in the equation of the circle, 9 plus 16 plus 24 minus 40 plus 16 plus 16. Now 16 plus 24, 40 minus 40 cancel, that equals to 25. S11 equals to 25, it is greater than 0, then the given point lies outside of the circle, then option is second option. Second option. The power of the point 1, 2 with respect to the circle x square plus y square minus 4x minus 6y minus 12 equals to 0. X square plus y square minus 4x minus 6y minus 12 equals to 0. Require the power of the point 1, 2. If suppose a circle, the center of the circle C, P is any point, P x1 y1 be any point anywhere. It may be outside of the circle or on the circle or inside, anywhere. The point P x1 y1, it may be outside of the circle or on the circle or inside. And radius of the circle is r. Now CP is the distance between, CP is distance between center of the circle and the point P. CP is the distance between center of the circle and the point P, and R is radius of the circle. Then CP square minus R square, CP square minus R square is called power of the point. Power of the point with respect to the circle, power of the given point P with respect to the given circle. If suppose circle equation, general equation x square plus y square plus 2gx plus 2fy plus c equals to 0. Now center of the circle is minus g comma minus f, and radius of the circle equals to square root of g square plus f square minus c. Radius equals to square root of g square plus f square minus c. Consider p x1 by 1. P x1 by 1 is any point. Now CP square minus R square equals to CP square nothing but square of the distance between center of the circle and the point P x1 by 1. Now CP square equals to x1 minus of minus plus g whole square plus y1 minus of minus plus f whole square minus square of the radius minus of g square plus f square minus c. Now further simplifying, we get x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. It is nothing but S11. It is nothing but S11. Means the power of the point P x1 by 1 with respect to the circle S equals to 0 is S11. The power of the point P x1 by 1 with respect to the circle S equals to 0 is S11. Now given point 1 comma 2, given circle x square plus y square minus 4x minus 6y minus 12 equals to 0. Now S11 equals to, substituting the point 1 comma 2 in the equation of the circle, 1 plus 4 minus 4 minus 12 minus 12, or that equals to minus 23. Minus 23. The power of the point 1 comma 2 with respect to the given circle is minus 23. Now here S11 less than 0, then the point lies inside of the circle. Answer is 1. Power of the point minus 23. First option. The radius of the circle passing through the point 6 comma 2 and 2 of whose diameters x plus y minus 6 equals to 0 and x plus 2y minus 4 equals to 0, and its two diameters equations given x plus y minus 6 equals to 0, x plus 2y minus 4 equals to 0. Now the circle, any straight line passing through center of the circle, then that line is called diameter. Given equations of two diameters, one is x plus y minus 6 equals to 0, second x plus 2y minus 4 equals to 0, are diameters of two diameters of the circle, and the circle passing through 6 comma 2. Now required radius of the circle. Now by solving the two equations, of two diameters, we get center of the circle. By solving two given equations, we get center of the circle. After that, the distance between center and the point 6 comma 2 is radius of the circle. Now by solving two equations, now from first equation subtract second, minus 5 minus 2 equals to 0, then y equals to minus 2. Now y equals to minus 2, substitute any one of the equation, or in first equation substitute x minus 2 minus 6 equals to 0. Now x equals to 8. Now center of the circle is 8 comma minus 2. Center of the circle 8 comma minus 2, and the circle passing through 6 comma 2. Now the distance between two given points is radius. Now radius of the circle equals to square root of 8 minus 6 whole square plus minus 2 whole square, or that equals to square root of 4 plus 16, or that equals to root 20 or 2 root 5. Now radius of the circle is 2 root 5. Second option. if alpha comma beta are roots of the equation x square plus ax plus b equals to 0 and gamma comma delta are roots of the equation y square plus cy plus d equals to 0, y square plus cy plus d equals to 0, then the equation of the circle having the line joining points alpha comma gamma and beta comma delta are extremities of diameter as diameter. Now, the alpha comma beta are roots of the first equation x square plus ax plus b equals to 0. Gamma comma delta are roots of the equation y square plus cy plus d equals to 0 given. If suppose alpha and beta are roots of a quadratic equation, then the quadratic equation is x minus alpha into x minus beta equals to 0. But actually alpha and beta are roots of the equation x square plus ax plus b equals to 0. Then x minus alpha into x minus beta is same as equals to x square plus ax plus b equals to 0. Similarly, gamma comma delta are roots of the equation y square plus cy plus d equals to 0. Then the equation whose roots gamma delta is x minus gamma into, in terms of y minus gamma into y minus delta equals to 0, or that equals to y square plus cy plus d plus d. Now, required equation of the circle alpha comma gamma and beta comma delta are extremities of diameter. If suppose x1 y1 and x2 y2 are extremities of diameter, then equation of the circle is x minus x1 into x minus x2 plus y minus y1 into y minus y2 equals to 0. The equation of the circle whose extremities of diameter x1 y1 and x2 y2 is x minus x1 into x minus x2 plus y minus y1 into y minus y2 equals to 0. Now, required equation of the circle whose extremities of diameter alpha comma gamma and beta comma delta. Just to the two equations adding we get, means x minus alpha into x minus beta plus y minus gamma into y minus delta equals to 0. Now, just adding two equations we get x square plus y square plus ax plus by cy plus b plus d equals to 0 is the required equation of the circle. Just adding the given two equations we get equation of the circle. Now, first option is the correct. The circle described on the line joining the points 0, 1, a, b as a diameter cuts x axis in 2 points whose abscissae are roots of the equation. Now, the circle whose extremities of diameter given 0, 1, a, b, 0, 1, a, b are extremities of diameter. Now, that circle intersect x axis at 2 points. If suppose at x1, 0, x2, 0, the circle whose extremities of diameter 0, 1, a, b intersect x axis at 2 points. 2 points consider x1, 0, x2, 0. Required the quadratic equation whose roots are x1 and x2. The quadratic equation whose roots are x1 and x2. Now, actually the equation whose extremities of diameter 0, 1, a, b is x minus 0 into x minus a, x minus x1 into x minus x2 plus y minus y1 into y minus y2 nothing but b equals to 0. Now, it is the equation of the circle whose extremities of diameter 0, 1 and a, b, 0, 1 and a, b but it intersect x-axis in 2 points. On x-axis always y coordinate will be 0, y equals to 0. In the equation at place of y equals to 0 substitute, we get x minus 0 x into x minus a plus y value 0, 0 minus 1 into 0 minus b equals to 0. Now x square minus ax minus of minus plus b equals to 0. Now the required equation, quadratic equation whose roots x1 and x2 is x square minus ax plus b equals to 0. X square minus ax plus b, second option. The lines 2x minus 3y equals to 5, 3x minus 4y equals to 7 are two diameters of a circle of area 154 square units. 154 square units. Then the equation of this circle, now circle, given equations of two diameters, now diameter of the circle always passes through center, given two diameters, then the point of intersection of two diameters is center of the circle. Now by solving two equations we get center. By solving two equations we get center of the circle. Just solving two equations we get center 1 comma minus 1. Center of the circle is 1 comma minus 1. Just to solving two given equations we get center 1 comma minus 1. If radius of the circle is r units, then area of the circle equals to pi r square. But pi r square equals to 154 square units. Given area of the circle 154 square units, then pi r square equals to 154. But the value of pi is 22 by 7 into r square equals to 154. 22 7 times cancel. Now r square equals to 49. Now square of the radius equals to 49, or radius of the circle 7. Center 1 comma minus 1 and radius 7 units, required equation of the circle. Now equation of the circle with center 1 comma minus 1, x minus 1 whole square plus y minus of minus plus 1 whole square equals to r square 49. Further simplifying, we get x square plus y square minus 2x plus 2y minus 47 equals to 0. Now it is the required equation of the circle whose two diameters 2x minus 3y equals to 5, 3x minus 4y equals to 7 and its area 154 square units. Then second option is correct. A circle of radius r passing through origin meet the axis at A and B. The locus of centroid of the triangle OAB. Now a circle passes through origin. Meet the axis at A and B. Now OAB is a triangle. Required locus of centroid of the triangle. Now centroid considered G, required locus of centroid. Now if suppose triangle OAB, in triangle OAB angle O equals to 90, because angle between coordinate axis is 90 degrees, then triangle OAB is a right angle triangle, then AB is the diameter of the circle. AB is the diameter or hypotenuse of the triangle. Now radius of the circle given r units, then length of the diameter equals to 2r. AB equals to 2r. Now consider centroid equals to x1 y1, required locus of centroid of the triangle OAB, and also consider the coordinates of the point A, 0, coordinates of the point B, 0, B, O 0, 0. by using the points 0, 0, a, 0, 0, b, then centroid of the triangle OAB is a by 3, b by 3, but that equals to x1 by 1. That equals to x1 by 1. Now, the values of a and b in terms of x1 by 1, a equals to 3x1, b equals to 3 by 1. A equals to 3x1, b equals to 3 by 1. Here a nothing but OA. OA equals to 3x1, OB equals to 3 by 1, AB equals to 2R. AB equals to 2R. But triangle OAB is a right angle triangle, then side square plus side square equals to hypotenuse square. Side square plus side square equals to hypotenuse square. Now OA square plus OB square equals to AB square. Now OA square nothing but 9x1 square plus OB square 9y1 square AB square 4R square. Then locus of x1 by 1 is 9 into x square plus y square equals to 4R square. 9 into x square plus y square equals to 4R square. Then fourth option is the correct. Fourth option. The equation of the circle passing through the points 0, 0, 0, a, 0. Required equation of the circle passing through the points 0, 0, 0, a, 0. Now 0, 0, it is nothing but point of intersection of coordinate axis or origin. 0, a, it lies on the y-axis point at a distance a units from origin. At a distance a units from origin. Similarly, a, 0, it lies on the x-axis point and it also lies at a distance a units from origin. Now, the given points form a right angle triangle. The given points form a right angle triangle. Required equation of the circle passing through the points, passing through 3 points. Then the 3 points form a triangle. The triangle consider OAB. OAB. Now AB is the diameter of the circle. AB is the diameter of the circle. Now a, 0, 0, a are extremities of diameter. Required equation of the circle. X minus a into x minus 0 plus y minus 0 into y minus a equals to 0, because x minus x1 into x minus x2 plus y minus y1 into y minus y2 equals to 0. Now further simplifying, we get x square plus y square minus ax minus b minus ay equals to 0. Now the required equation of the circle x square plus y square minus ax minus ay equals to 0. Second option. Second option. Two rods of lengths A and B. A and B. Slides along the axis which are right angle in such a manner that their ends are always concyclic. The locus of center of the circle passing through these points. The locus of center of the circle. Now, two rods of lengths A and B slides along the coordinate axis. If suppose one rod on x axis, another y axis. Now, a circle passes through 4 ends of the rods. Consider AB is one rod and its length A, CD is second rod and its length equals to B. Always the ends of the rods are concyclic, require the locus of center of the circle. Locus of center of the circle. If suppose center of the circle, consider x1 y1. Center of the circle x1 y1. Now center x1 y1, then the equation of the circle must be in the form of x square plus y square minus 2x1x minus 2y1y plus some constant k equals to 0. Because center x1 y1, center of the standard circle nothing but minus g comma minus f, minus half of the coefficient of x comma minus half of the coefficient of y. Now in this case, half of the coefficient of x minus half of the coefficient of x is x1, minus half of the coefficient of y is y1. Now the center of the circle is x1 y1, then equation of the circle must be in the form of x square plus y square minus 2x1x minus 2y1y plus some constant, any constant k equals to 0. Now here AB nothing but the length of intercept made by the circle on the x-axis. Length of intercept made by the circle on the x-axis. Now length of intercept made by the circle on x-axis equals to 2 into square root of g square minus c. 2 into square root of g square minus c. Now that equals to 2 into square root of here g nothing but x1 square minus k, but it is equals to a. 2 into square root of x1 square minus k equals to a. Similarly, CD nothing but length of intercept made by the circle on the y-axis. Length of intercept made by the circle on the y-axis, that equals to 2 into square root of f square minus c. 2 into square root of f square minus c. Now that equals to 2 into square root of y1 square minus k. But length of the second rod equals to b. 2 into square root of y1 square minus k equals to b. Now from these two equations, eliminating k, we get the required locus of x1 y1. Locus of x1 y1. Now both equations square, and from first equation subtracting second, 4 into x1 square minus y1 square equals to a square minus b square. Therefore locus of x1 y1 or locus of center of the circle is 4 into x square minus y square equals to a square minus b square. The locus of center of the circle is 4 into x square minus y square equals to a square minus b square. Third option. The shortest distance from minus 2 comma 14 to the circle x square plus y square minus 6x minus 4y minus 12 equals to 0. The shortest distance from minus 2 comma 14 to the circle x square plus y square minus 6x minus 4y minus 12 equals to 0. If suppose a circle, center of the circle consider C. Let C be the center of the circle. P is any point. It may be outside of the circle or on the circle or inside, anywhere consider. If suppose first to consider the point P lies outside of the circle. Now the distance between center and the point P is CP. CP is the distance between center of the given circle and given point P. Radius of the circle R. Radius of the circle equals to R units. Now the shortest distance from the point to the circle, the shortest distance from the point P to the circle. Now PQ equals to CP minus CQ. Or that equals to here CP minus CQ nothing but the radius of the circle. CP minus R. If suppose the point P lies outside of the circle. Similarly, if suppose the point P lies inside of the circle, draw radius through P, it is considered Q. Now in that case PQ is the shortest distance. Now PQ equals to, we get CQ minus CP. CQ nothing but PQ equals to CQ minus CP. or that equals to here CQ nothing but radius of the circle. Always the distance between center of the circle and any point on the circumference is called radius. Now R minus CP, then the point may be outside of the circle or inside of the circle, then shortest distance equals to CP minus R modulus, CP minus R. Shortest distance equals to CP minus R. Similarly, the greatest distance from P to the circle equals to CP plus radius. CP plus R is greatest distance. Here also greatest distance equals to greatest distance from the point P to the circle equals to CP plus radius. CP plus R equals to greatest distance. Now CP minus R modulus is shortest distance. Now center of the given circle C equals to 3, 2 and its radius R equals to square root of G square plus F square minus C, 9 plus 4 minus of minus plus 12, or that equals to 5. Now center of the circle 3, 2, radius of the circle is 5 units. Now given point P minus 2, 14. Now distance between center and the point P, CP equals to square root of minus 2 minus 3 whole square plus 14 minus 2 whole square, or that equals to square root of 25 plus 144, that equals to root 169 or 13. The distance between center and the given point is 13 units. Required shortest distance nothing but CP minus R, but CP equals to 13 and radius of the circle is 5. CP minus R equals to 13 minus 5 equals to 8. Now shortest distance equals to 8. Similarly, if suppose the required greatest distance CP plus R, 13 plus 5, we get 18. Now shortest distance equals to 8. Then first option is correct. First option. The equation of the tangent at 1, 1 to the circle 2x square plus 2y square minus 2x minus 5y plus 3 equals to 0. Required the equation of the tangent at 1, 1 to the circle. If suppose the circle equation S equals to 0, then equation of the tangent at x1, y1 to the circle S equals to 0 is S1 equals to 0. Now, but by using the formula S1 equals to 0, we get calculation is very lengthy calculation we get. Now, the given equation consider S equals to 0. The given equation of the circle consider S equals to 0. Then slope of the tangent M equals to minus dou S by dou X by dou S by dou Y. Slope of the tangent at given point 1, 1 is minus dou S by dou X by dou S by dou Y. Now minus of differentiate partially with respect to X, we get 4x minus 2 by with respect to Y differentiation 4y minus 5 at given point 1, 1. Now substituting 1, 1 in the equation, we get 4 minus 2, 2 minus 2 by 4 minus 5 minus 1, or that equals to 2. Now slope of the tangent equals to M equals to 2, but the tangent passing through 1, 1. Now equation of the tangent or equation of the straight line passing through 1, 1 with slope 2. Y minus 1 equals to M into x minus x1 or x minus 1. Further simplifying, we get 2x minus y minus 1 equals to 0. The required equation of the tangent to the given circle at the point 1, 1 is 2x minus y minus 1 equals to 0. Second option. The equation of the normal to the circle x square plus y square plus 6x plus 4y minus 3 equals to 0. at 1 comma minus 2, at 1 comma minus 2. Now circle, if suppose P is a point on the circle, P is a point on the circle, tangent, it is tangent to the circle. Now always tangent and normal perpendicular to each other, normal. Now but radius of the circle also perpendicular to tangent, means normal of the circle always passes through center, always passes through center of the circle. Now given point 1 comma minus 2, center of the given circle minus g minus f, minus 3 comma minus 2, center minus 2, minus 3 minus 2. Now required equation of the normal, it is nothing but equation of the straight line passing through the point minus 3 comma minus 2 and 1 comma minus 2, passing through minus 3 minus 2, 1 comma minus 2. Now passing through these 2 points, observe it, in 2 points y coordinates are equal, then equation of the line is y equals to minus 2 or y plus 2 equals to 0. The equation of the required normal y plus 2 equals to 0. Second option, y plus 2 equals to 0. Second option.